had a question. Like when we were discussing like from where the database comes, like when you told us like from where the data comes, you said like it comes from the database or the user. So like how does users provide database?
So it comes through the screens, right? So let's say you have a screen, and maybe let's take a customer registration form. Now you'll enter some data, right? So if you pick up something, a screen like this, you're entering all this data, and then when you click on submit, right? It either goes into your database, or maybe if it has to go to some other system, it goes through to an interface, right? Most of the times what they do is they would store into a database and then it would be transferred. So even though it's directly coming in from the user input, you generally store that in somewhere in your system as well and then send it out, right? But yeah, that's context. Did that clear your question, or you're still confused where the data?
But then this information will also go to the database, right? Like when we do a transaction, like a transaction through internet, like when we're buying something, a shopping, then also the information is stored in a database.
Right. So you generally store it in your system and then send it out. So most of the times, you would create. There would be some temporary databases, and then you store that. Right. So to an extent, what you're saying is right. Most of the data gets stored in your system, and then you would, send it out. But some of the data could not even come in from the screen. So that's what I meant. Right. So there are two ways. So you're not even capturing the like let's say the credit card details. Right. So you're only capturing the amount. So the amount might get stored in the database and come in, but the credit card details are already in the database, and we are not even capturing that. Right. So that's the difference.
Okay. Okay. And the other thing is, can you explain the exception handling?
So we're looking at this requirement, and where you are, the functionality is that you are buying something on the internet on a shopping cart application. Then you send that card details and the amount to the the payment network provider, like MX. MX would authorize the transaction and send back a response. So that's the overall functionality which is involved. Right? So some information needs to be sent and some information needs to be received. So there are two stages of two messages which are exchanged. So the first one is where you're sending in all the card details and the amount which needs to be deducted, and you'll clearly call out all the details as part of your input, right? So this would be in line with the discussions with this the solution owner or business analyst from the other system. You'll both you guys would sit down and then figure out this format and then agree on to it. Okay. Similarly, when the response comes also, you will agree on to the format. Right. Now, it's not just about these interfaces. So something could go wrong as well. Right. So what if you're sending this message and the system is down? Right. So you have sent this message and you're waiting for a response. Now you cannot wait forever. Right. So you should say that, okay, maybe after 20 seconds or 30 seconds. We should display. You should cancel the transaction and display a message to the user saying that your transaction cannot be processed further because the system is not available. Something like that, right? So figure out all those things where something would go wrong and then list down as exceptions. So as I see it, in this case, there could be a network breakdown when you're sending this message, which means you have not sent this message yet, and so the message is lost completely, right? And the second scenario would be, maybe, this system is down, right? And so your response is lost, your input is lost, and you won't get any response. The third scenario would be, you've sent your input and this system has processed it, but when it's sending out a response back to you, there was a network breakdown. Okay, so all three possible different scenarios wherein the transactions fail. Right now, in this case, let's say when the input is when you have sent in the input and the network breaks down, so it doesn't reach Amex, right? So Amex will not process it. So obviously there is no problem with it, right? So you'll just display a message saying that your transaction is not processed because the system is down, right? The second part of it, where this system is also down, so the transaction is not processed because it cannot process the transaction. The system is down, right? But in the third scenario, wherein you have sent in a transaction, right? You sent in the input. This guy has deducted the money, right? He's deducted the money from the card. But when the response is being sent, the network breaks down. So in this scenario, there is a disconnect between the system. This guy thinks that the transaction has not come in. There is no response from this guy. So after, he will wait for 30 seconds and then say, okay, what? The transaction is cancelled. But this guy is already deducted the money. Right? So you'll have to figure out how to reconcile between these two systems. So maybe you'll raise that as a exception file, and then manually reconcile. Okay, there are 10 transactions which happened during that time. So 10 of them will look at it, and then if this guy is already deducted, then either you will process this or you cancel and refund the payment. So some action would be taken, right? So those are all the exceptions which you'll have to manage. Okay. So typically, this is how an interface would work between two systems. Now, what we have looked at is a real-time interface. Not all interfaces needs to be real-time. Why? Because some systems don't have that business need, and it need not be real-time. So developing a real-time interface is a little more effort consuming, and the second disadvantage is that it stops the process in between, right? So if the interface fails, then your business could be affected. I'll give an example for that also. So first, let's look at an example where we do a batch interface. Now, we all use this internet banking, right? Now, as part of this internet banking, now if you had some, if you wanted to create a fixed deposit, right? So there's a process where you can just create a service request, and then you'll get a message saying that, we got your service request and we'll activate your fixed deposit by end of day. So the fixed deposit is not created at that same moment. Why? Because it's not required at that time from a business criticality point. They will say, okay, we took your request, you will get your fixed deposit ready by tomorrow morning. Okay. So all you're doing is you're taking that request but not processing it at that same moment. What you will do is you will pick up all the requests which have come in for the day and then collate it together and process it in one go. So this way you don't have to have that real-time connection between the deposit system and the online banking system, right? So every day at the end of, let's say at 5 p.m. End of day, you would collect all the records requests that have come in. If 10 requests came in, you will write it into a file of those 10 records, and then that records you will send it to the deposit system. The deposit system would read those 10 records, then create those 10 deposits, and maybe then it will send out a confirmation message saying that all those deposits are submitted. So effectively, that is a process that you would follow. Right? The advantage of this is, for each and every record you don't have to process it. Okay. So the effort would be a little bit lesser because there is no real-time interface, you don't all you have to do is all the records you'll have to store into a database, and at the end of it you'll have to create a file, right? You'll have to write a file with all those records into that file, and then the file is being sent to the other system, right? A very simple way of handling it, right? Now for batch interface also, the process is the same. You'll have to capture all what data points that are being exchanged. So online banking should capture some details about the fixed deposit. So you'll check with this guy, what all details do I need to capture for creating a fixed deposit. Then you would ensure that the fixed deposit screen that you're creating, captures all these details, and then you'll also capture the metadata. Okay, and then once that is captured, it's written into a file. That file is sent. So you'll agree on the file formats also. The technical team would agree whether it's a CSV file, XML file. Right? So all that details would be agreed between the technical team, right? And finally, you'll create files, right? So a typical, the simplest of all files is a CSV file, right? So this particular example, if you look at it, it has some 4 records in it. Okay. Now 4 records, because there are 4 different lines in it, right? So each line would mean that it's a new record. Okay. And within the line, all the columns are all the data points are separated by commas, right? So there is a date. If you look at it, look at the file format, you have agreed on this 1, 2, 3, 4, 5 data points. You have agreed on date, the amount, the savings account from which the amount needs to be deducted, how many months the fixed deposit is, and what is the interest rate. Right? So these are the 5 things that have to be sent. Right? So first you're specifying the date, comma, this is the amount, then this is the account number, savings account number from which the amount needs to be deducted. This is the number of months, and this is the interest. Right? All you're doing is you're separating them by a comma, and then capturing these details, these 5 details. Okay. So this is the simplest of file. So at the end of the day, what you do is you'll read from your database. Your database would consist of details like this, right? So when the request came in, it would have written to this database, and from here you will extract it, create this file, and place it onto a file server somewhere. Okay. So the file server, the deposit system would pick it up from that particular file server, right? So then ideally it would be somewhere like, rather than sending it here, it won't be sent to the system directly. There would be a file server somewhere, which you place. File server somewhere which is placed, right? So this is actually going in here, and then it comes here. Okay, so the files will be read from that file server. Okay, so it's nothing but it will be placed in some one particular folder which is accessible by both the systems, right? And that's how it would be read. Okay, so clear about this process. Now there are different file formats, right? So we have looked at a few of them. We looked at CSV file and all. But let me give you a little more detail about there's another format which is XML format, right? Which is a little more flexible compared to the CSV file, right? So let's look at that, and then we'll also understand about APIs. So that's what would be the focus of today's session. Right. So typically in a CSV file, it's hard coded. All those details are hard coded, right? Now let's say we also want to add the phone number. Just for the sake of it, I want the phone number also to be captured as part of the interface file, right? Now a person can have multiple phone numbers, right? So your CSV format is inflexible. So if I have to add one more column, it has to be only one record in it. So I cannot have, like, for one customer 3 mobile phone numbers added in the case of CSV, right? So in that case, I would have to change it to, let's say, mobile number 1, mobile number 2, right? So something like that. I have to add additional columns here, right? Now, one person might have 2 or 3 mobile numbers. Most of the people will have just one. So there, you're creating this additional columns which will always be blank, right? So that way, this CSV file format is inflexible. So you have to define the columns up front, right? CSV provides us with a little more flexibility. So what it says is it allows us to define our record and flexible formats for the record, right? Like in this case, if you look at the at this particular file, this is much more easy to read compared to this file, right? So it says that first record, the date is 5th May, the amount is 100, 2342134 is the savings account number, period is 12 months, and interest rate is 8%, right? So here that details are not coming out, but in the XML format, each of the record, the data that you are sending in is shown between the tags, so it's clearly it's clearly visible, right? So we can read through and then understand what it is, right? So that's the advantage of an XML file, right? Now there would be programs written to create this file and read from this file. We call them as XML parsers. The technical team would do all that, okay? But in case you are given an XML file and asked to see whether this data is right or not, all you have to do is open. If you open it, it generally opens up in a browser, in an Internet Explorer, okay? So it's easily readable, right? And you can know that these are all the file records in it, and it can have nested data as well, right? What it means is within this file you can have something like an address, and 3 addresses could be mentioned in it, right? So that's the flexibility of XML, right? So people tend to use XML where there are the data is a little complicated, right? But you are not going to decide it. So it's only more like an additional information that you are gaining, knowing, right? So if you are asked to look at this file, this is how a typical XML file would look like, right? So very simple to understand. You will have the tags and then the data in between the tags, so you can figure out which data what it is. Okay. So you understand this file format?
Yes.
Okay, great. Let's move on to the next topic, which is the APIs, right? Now consider this situation. There would be some scenarios wherein you'll have to integrate with some hundreds of systems, right? So you will provide some services which some hundreds of systems are using. You cannot go and then decide the interface individually with each one of them. It's impossible. A classic example is the same one what we have just discussed here, right? Between MX and then different shopping carts, right? Now MX provides an interface or processes the payment for multiple organizations. So it need not be MX. It could be there are multiple other websites which are accepting online payments, and everybody has to decide, check, discuss it with MX and then figure out what is the file format, and then agree on to this file. So for MX, you cannot obviously go and talk to each and every vendor who is out there in the market and then agree on to the file formats. Practically not possible for them. So what they do is they will say, since multiple there are so many people of you who are using my interface, I will decide the format. Everybody has to agree to it, right? If you want to use my service, you just have to agree to it. Okay. So all these data format, the file, all these details are just specified this one guy, right? And you will not get a chance to talk to these people and then sit down and then discuss that file formats. The file formats are not flexible. So MX specifies this file formats. You just have to understand it and ensure that you prepare the file format in that particular structure and then send it to MX. Right? So if the interfaces are defined by one guy itself and the other person adhere to it, right? So that is called as an application program interface. So what it means is MX is providing some service. It's basically authenticating your payment. Right? It's processing your payment. Now, to process the payment, it needs some data points, and it will specify those data points which it needs to come in a particular format. Okay, the format and all will be defined by that guy, and you have to adhere to that format to send that details into it, and then you get a response to it. Right? So the interface is more or less similar, just that rather than having that joint discussion between these two guys and then agreeing onto these file formats, only one guy is doing it. Right? So in a layman's term, to understand an API, that is what happens. Okay. So let's look at an example as well. So I'm picking a similar kind of example like mastercard. Right? So when we're talking about that, they would have their own APIs. So let's say there is a bill payment which can happen. Okay. Now there would be some process in which the overall bill payment would work. Right. So it will give you some details about it, the introduction and functionality. What are the steps involved in the processing and all. Right. So this is nothing but your functionality. Okay. So functionally, so if you look at it, the interface specification file would be similar to what the APIs are. Now this is an API for bill payment, right? So he has covered it in 4 or 5 sections. I'll go through that anyway, right? So broadly, he will talk about the functionality, right? And then he will also give you maybe additional clarifications. You can contact them. Okay? He's explaining you the functionality. Right, so the steps involved in it. So from a functional point of view, you have to understand that. Then he would also, so all this is talking about the functionality. The overview is about the functionality, introduction and functionality. Right. Then he would tell you where exactly you'll have to send the request to. Right. Now usually there are 2 environments. One is the testing. We call that as a sandbox environment. So if you want to test the interface, right, you have to send it to this particular address. You have to create the program, and that program has to be sent to this over the HTTP protocol to this address. And in case of the real-time environment where you actually want to use real-time functionality, you'll have to use this URL. Right? So he will tell you what format the file has to be in. The file has to be in an XML format. He will tell you what is the protocol and technology, HTTP protocol, right? And all those details he will give you. Then he comes over to the details about the metadata, right? So the metadata, what needs to be set, the various data points, and then the metadata about it. So the request parameters. So this is basically the request coming into the mastercard, and then there would be a response out, right? So you'll cover all these. Mastercard would clearly specify that he would need an RPPS ID, then a biller ID, account number, transaction amount, customer identifier 1, 2, 3, 4. So he's specifying all these details have to be there. Then he would also capture the metadata. So he's giving a small description about it. He's giving the details of whether it's mandatory or optional. So it's saying this is required, and then it has to be a text or a string, and 8 is the maximum size of this. Right? And he's also giving you an example. Right? So the description, the metadata, and an example for each and every parameter that he's providing here. Right? And then he would also explain you using an example. So this is a HTTPS post, and then the headers have to be this, and then the XML file format would look like this. You're sending it for bill payment account validation. So RPPS ID has to be there. So if you look at each of these fields, he has said, you need an RPPS ID, biller ID, account number, transaction amount, and all. Right? So all those details would come in this format. Okay, XML format, RPPS ID, biller ID. All those details are coming out in this one. Okay, so pretty much he is clearly telling you how the file formats and how the details have to come to him. Then he'll also specify about how the response would be. So he's giving each of the details that would come out in the response, which are more or less similar to that one. And then finally you'll have one response string saying whether it's successful or unsuccessful or whatever it is. Right? So it'll give you all those values, which can what are all are expected here, right? So that's onto it. Then you would also provide some various error codes, right? So if some account number is not valid, right? So what is the error message which should be displayed, right? So if you get an message saying invalid account number, that means the account number is not valid, right? Or if it's an invalid biller ID, you'll get this message. So it's clearly calling out all the error messages and exceptions, right? So all those exceptions and then the the error codes are clearly defined as part of the error codes as well, right? And then the rest of it is of use to us. Sandbox is basically a testing environment kind of thing. He's giving you some test cases where you can actually send these data points and then get a response, right? So if you send for this RPPS ID, biller ID, account number, and transaction amount, there would be a successful validation, right? So it's giving you some test cases. Then he's giving you an option for discussions happening as well, right? So you can, if you have any questions, you can post it into your discussions board, right? And then maybe a sample code, right? So these discussions and sample code might not be there in all of the APIs, but what you will definitely have is the overview. Then you would have the format of the files. Then any test cases and some error codes as well. Okay, all that is covered as part of your APIs, right? So APIs actually make your life simpler. So you don't have to have that discussion and then figure out on the file formats and then the details, right? So you just pick it up from the internet. This they publish it easily, right? So you either they send out those API file format to you by email or some of the sites like Mastercard put it up onto your website as well, right? So you can look at those APIs and then adhere to that, right? So even Google has a lot of APIs. So if you are developing something, it will have all those APIs under it. So let me, yeah. Anyway, okay, it's opening up now. Right. So, these are all the features that you can use from Google, right? So if you want to add exchange by your API, it allows you to access your bidding account information, submits creatives for validation. So, based on the functionality, you can use that. I think let's pick the simplest one, which is your account validation one. And I think Yeah, let's say YouTube. Okay. So if you want to figure out what are all the, the list of channel activity which happens in YouTube, right, you could use this function, right? So all you have to do is you have to specify these details: part, channel ID, home. These are the data points that it is asking for, right? And then you authorize and execute it. So it will create that file format and all, right? So basically, the the other person, which is Google in this case, is clearly specifying what data he needs. And then if you provide that, then you can utilize that service, right? So that's exactly is what an API is for. All right. So yeah. So if you have to summarize what we learned in this overall last two sessions, we learned to look at what is our contribution into an interface. When our system has to interact with another system, how do we agree onto the functionality, the interactions between the systems, right? And then what data is exchanged at each of those interactions, right? What is metadata? How do we agree onto it, right? And then where does the data come from? Okay. So we looked at all that. We also looked at what the technical architect would do. They would focus on to the file formats and the syntax of it, the protocols of it, right? And then we would also look at the exceptions, the error codes, and all those details would be clearly captured as part of the interface specification, right? Other thing that I forgot to mention yesterday, some of them, some of your data points could have a master list, right? So like for example, currency. So you're not expected to enter any text what you want. You want to limit it to maybe so a list of all the currencies, right? Or maybe if you're dealing with only 4 currencies, let's say US, USD, and pound and yen, right? So in that kind of situation, you restrict it to only that 4 points, right? So here, rather than specify the size and everything, you will ensure that as part of the description you will say that the currency can be one of the master list, one of the values provided in table below, right? And then you will give a reference maybe. So you would capture that currency table somewhere, right? So you'll say currency, right? USD, then pound, euro, and let's say yeah, right? So it can be only one of these 4 values. So validations have to go perform that. It doesn't exceed more. It doesn't be anything outside than this. Okay. So you can bring in some master list values as part of your the data that you can enter. So that's also another thing which you have to take care during the requirements itself. Okay. So broadly, is it clear what we do as part of our interfaces? Any questions?
So what are the difficulties that comes? Like what are the queries and questions arise when like from clients and how the queries are raised?
See, if you're talking about the interviews or the actual process of the interview.
Yeah, during the actual process, like what are the shortcomings like?
Okay. Now, generally, first understand the functionality, right? So the way you should approach is, this interaction should be clear. Otherwise, you'll always be at the back of your mind, why are we doing it, or what is that we're trying to achieve, right? So the ideal process should be you first understand the functionality, right? So sometimes, both the parties itself will not be clear on what is it that we need to exchange and all, right? So these discussions about, the various data points has to happen, right? So what all data you need require. And sometimes, the kind of difficulties what you have is, one system would have data and the other system would consider it as another type. For example, your credit card number, right? So though it's a number, you're not making any, calculations on it. So some other guy, let's say, the other guy has stored it as a text, right? So because you're not doing any manipulations, it's not a number actually. So since though you're giving it as a number, but there are no, calculations which are happening. So you could store it as a, number. As a text, right? So one guy stores it as a number, other guy stores it as a text. So these kind of inconsistencies could be there. So you'll have, then your interface, you'll have to specify that, and then the technical team can handle it, right? So they will convert one number to a text or text to a number and then store it, right? So you'll arrive and then finally agree onto one format, right? So whether it has to be number or a text. Okay. So that's a lot of your time would be spent on figuring out what data needs to be exchanged and what should be the message format, right? Metadata won't take much time, but also figuring out where exactly from your database does this data coming from, right? So you'll have to understand the underlying data model. Okay, then only you can map it to this particular table and that particular attribute under the table, right? So this would always be there, right? So this is basically what you'll have to figure out, and the overall process, right? So it's not just saying the input and getting the response. How you are going to manage the exceptions, right? What in case some records fail, right? So are you going to resend it, right? Or are you going to make those changes manually and then enter it, right? So you'll have to figure out on all those exceptions and then exception handling process. Okay, all that would generally be part of your interface specifications. Okay, so broadly that is what we do. If data needs to be exchanged, we figure out what data needs to be exchanged, what is the sequence of events, and under each sequence what data you're exchanging, the metadata about it is generally captured. Okay.
Okay.
Now your interface specification would be part of your BRD. When you're preparing your business requirements document, whatever details you have understood, you'll document it in this format, and then that would generally be a section for interfaces in your BRD. You'll capture it there. Okay. So that's for onto the interfaces. So to quickly summarize, we learned the various techniques in which we could understand the requirements. We also learned about how to agree onto the interface formats. So by now we have all the techniques which needs to be to understand the requirements in detail. Okay. Now what do we do after we have that understanding about the requirement? We start documenting it into a BRD. So there are multiple techniques that you would use for documenting the requirements. So the next 5-10 sessions would focus on how do we document our requirements. Okay. Now ideally your elicitation and documentation happen simultaneously. Like maybe a couple of hours you'll spend in elicitation. After your requirement is clear, you'll go back and document. The only reason why we are covering them as separate topics is because the techniques are different, and it's easy to focus on each topic at one time. We have segregated that as part 3 and 4. But it's not like part 3 happens, then only you'll move on to part 4. Part 3 and 4 happen simultaneously at the same time. Okay, chapter 3 and 4, you're actually doing your work at the same time. Okay, so quickly I'll give you the overview about what kind of techniques that you would learn, since we have a few minutes, and next session I will start off onto the topic. I'll broadly give you an overview about what all techniques you would learn, and then we would continue from there, right? So during the early days, when the program languages used to be like mostly procedure oriented, so like your Pascal or Basic and all, wherein you had a process and then you tried to automate the process. So that was the underlying logic of programming. Right? So they used to first figure out what is the process, and exactly they used to write a code to automate that process. Okay, so that was the first generation or first kind of programming languages, right, which were widely used, right, and the analysis techniques that we use for those procedure oriented languages were data flow diagrams and ER models. Okay, so data flow diagram basically to explain how is data flowing within your organization or within the scope of the system, and how is it processed. So in a way, it showed how is data flowing from one person to another person, and what is the modifications they're doing, and what is the final output. Okay, and ER models showed how is data stored in the system. Okay, so we still use the ER models because it's still relevant with respect to databases for designing the databases and all. But data flow diagrams are outdated, so we don't really use them because people moved on, and rather than using structured analysis or procedure oriented languages, a lot of the programming languages these days are object oriented. You pick up Java or .NET and all are all object oriented. So the way you would design your systems also has changed. Object-oriented analysis is primarily based on UML, Unified Modeling Language, is the modeling language which should, help you analyze the system and, not only capture the requirements but also help in the high-level design. Right? So overall, it will help you model the system. Before you actually start your coding, it will help you model your system. Right? Now it's a set of 9 diagrams. UML has 9 diagrams in it, and one diagram captures the functional requirements, which is the use cases. Right? And the responsibility for the use cases would be with us as a business analyst. Then most of the other diagrams are with the technical architect. Okay. So we need to be experts in writing use cases. So we'll see what all details goes into a use case and all that, when we talk about object-oriented analysis and design. But that's one of the most widely used ways of capturing the requirements these days. Use cases. Okay. So use cases would be used for capturing all your functional requirements. Then you would capture the non-functional requirements also, and finally at the end of it, you will create a business requirements document. Okay. Along with the use cases, there are multiple other formats which you tend to use, which are not so which don't exist on their own, but in conjunction with your use cases. Which means some of those techniques could help you in elaborating the details furthermore, rather than write it in a English paragraph. Something like your screen flows or your wireframes, your process flows, flow charts, mind maps. Right? There are multiple other techniques that you might need to know. Right? So we'll also learn all those various techniques as well. Okay. Now, all these are generally used as part of your traditional SDLC life cycles, like waterfall, iterative, prototyping, and all these models would use this use cases and then the other representation techniques to capture the requirements. Okay. Of late, these days, agile ways of executing the projects are becoming very popular. Okay. All you will, so agile is a completely different way of executing the projects. So we'll look at it later. But it deviates from the the traditional SDLC, and then it captures the requirement in a completely different way, and even executes them in a very different way. It's a lot collaborative and focuses less on documentation, right? So we need to understand how agile programs work, specifically the Scrum model, and then understand how do we document the requirements using user stories, right? So broadly, these are the 4 different areas that you would look at. The most important ones among these are the use cases and the user stories. right? So the rest of them help us in documenting the requirements in a little more elaborate way. But broadly, the core topics are use cases and the user stories. Are you able to follow through? I mean, what you're doing? How did you plan? How did you understand the requirements? Now you're trying to document the requirements, right? So we are going in the way a typical project would approach, right? So you first spend your first week, 1 week planning for the project. Then you would understand the requirements and then you would document it. Though it happens simultaneously, first we focused on all the techniques that you could use for understanding requirements. Now would focus on all techniques to document it. Okay.
So what takes longer time, requirement gathering or documentation?
See, understanding requirements, you will spend like maybe a couple of days every day. But to document it would take a little longer. Right? So because you have to think through it, and then maybe you'll have to create those screens, visualize it, right? And then you'll go back and validate it and again, right? So that as part of prototyping. But a larger part of your time you spend in documenting it, right?
Okay.
So understanding the requirement, maybe it could come out like maybe an hour or so, but you could spend some 2-3 hours in documenting it, right? So a typical day of yours would be like morning 1-2 hours you'll spend with the SME, understand the requirement, and spend the rest of the day documenting it.
So like when an interviewer asks like what is exceptional handling, how should we answer?
Exception handling in what? In the interfaces?
Yes.
Okay. Now see, generally again, let me give you first a practical view of how the interviews would generally go, right? Now they're not going to test your theoretical knowledge. So whether do you know what exception handling is or what it is, right? They would want to know how did you apply it, right? So in case you are posing some experience, they would definitely want to check in how did you do this in this project, right? So they would focus a lot more on the application. A lot of people who from the industry would want to know how did you apply it rather than whether you know what each of these topic means. Right? So there won't be questions, direct questions like, tell me about prototyping or what is vertical prototyping or horizontal prototyping or tell me about traceability, right? So there would be, rarely that kind of direct questions, right? Now what they would ask is, they'll pick up, one of the projects. They would ask, what all interfaces were there in the system, right? How did you go about figuring out the details about the interface? Right? Then you'll have to talk about all these points that this was the primary interface details, and then we had to capture these exception details. So that is where they will figure out, okay, what this guy has enough knowledge about each of these topics. Okay, so it will be a lot on application oriented questions rather than conceptual oriented questions, right? So if you are posing as a fresher, so then these kind of questions would come in. Now, if I have to answer specifically to your question about exception handling, what when some input comes in which you're not expecting, right, or something breaks down, right? So the system should be capable of displaying the appropriate message or handling it properly rather than just go blank, right? Now there could be some situations wherein, let's say, you have to send an valid account number, but you have sent an invalid account number. Now the system should be intelligent enough to understand that this account number is valid and this is invalid, and then display that appropriate message saying that you send me an invalid account number, please send me the right one.
Yeah.
Right? If so, that is basically you're handling that exceptions or errors, error handling and exception handling. Okay, but if this is not present, the system will get stuck. It will be showing up a blank screen or it will not respond to anything, right? So you will not know what went wrong. The system will not know what went wrong. So all you have to do is you'll get stuck at that particular screen, right? So to avoid those situations, you have to ensure that all your you know, errors and exceptions are handled properly. Okay, so that purely depends on the context and the functionality that you're after, right? So these are some questions which you can definitely ask the SME, right? How should the system respond if this data is not available? Then that appropriate error message has to be displayed. Okay.
Okay.
All right, then the next topic, which is the requirement documentation. Okay.